लवली एंड स्वीट टेस्ट ट्रेन। सो मैं आ गया हूँ आपका मेंटर माइंड एक नया प्रोजेक्ट लेकर जिसका नाम है ईएस। सो मैंने गलती से एक दूसरे प्रोजेक्ट पर मैं क्लिक कर चुकी हूँ जिसके लिए मैं वापस आ गया हूँ। सो इसके नाम है ईएस प्रोजेक्ट। ओके, सो मेरा साथ देने की कोशिश करना, मैं आपके साथ इसके बारे में बात करूँगा। साथ देने की कोशिश करना, क्या क्या होता है इसके बारे में ही मैं बात करूँगा। देखते रहना, मेरा मेरा साथ देना। ओके, so now I'm talking about that. Get LaunchPool newly added Eclipse ES stake BTC ETHES to earn rewards delivered in real time. Eclipse ES will be launched on Get LaunchPool stake BTC ETH ES to earn ES token rewards every hour. Airdrop details. Staking period July 16, 2025 at 10, July 26, 2025 at 10 UTC, and total staking rewards 919.000. I mean 9,90,000 ES. So stake to earn now. So then unlocking rule 100% unlock it. Launch pool allow user to stake early. You can stake your assets before the project officially launches, ensuring you start earning rewards immediately once mining begin. Then reward distribution. So the system will distribute a token rewards to user spot accounts every hour based on the proportion of asset stake by each user. And get launchpool frequency. How to participate? Log into your Get account and complete identity verification. So navigate to launchpool, hold at least 0.000001 BTC or 0.00003 ETH or 0.2 ES. Click stake. Exclusive staking limit privilege for VIP users. VIP 5 and above users enjoy exclusive staking limits when participating in Launchpool with up to 500% staking limit bonus. So VIP level, okay, everything is here. Then project information. Eclipse is Ethereum first Solana virtual machine as VM. L2 Eclipse combines the best pieces of the modular stack with Ethereum settlement as VM execution and Celestia for data availability. Each layer of Eclipse architecture is best in class and combined result in unstoppable performance. Eclipse is backed by leading investors including placeholder VC Hack, VC DVA, Polychain, Tribe and Perify as well as industry leaders including Mustafa Al-Bassam, Celestia, Tarun Chistra, Gauntlet, Robert Basie, Anatoly Voikovenko, Solana, Janier Sherwani, Jitu, Jetiago R. Santos, Parafi, Ryan Watkins, Since Crazy, Hasso, Flashboard, and other website. So then Eclipse website. So then notes number one. Get Launchpool in an innovative staking and Airdrop platform where user can stake GTBT, CTH, USDT or other token or to earn early airdrops of hot and new coins with low entry barriers and high APR. It's the ultimate platform of effortlessly capturing market opportunities. And number two, please complete identity verification before participating in Launchpool to enhance the security of your account and assets. And number three, please adhere to the relevant rule of the event when participating in initiating behavior is prohibited and occurrence of any dishonesty will result in the disqualification of the rewards. And number 4, where any discrepancy arises between the translated version and the original English version, the English version shall prevail. And number 5, get reserves all right to the final explanation. Number 6, this event is not affiliated with Apple Inc. And number 7, users in the United Kingdom and other restricted location cannot access the services including the participation in this event, game or competition. See the user agreement for further details on restricted location. Okay. And then risk warning. Number 1, the project team does not guarantee that token price will not be lower than its initial sale price. Please invest with caution and don't invest beyond your financial capacity. And number 2, the crypto project is still in its initial stage. Factors including the operation and underlying technology of the project and other related regulatory activities might contribute to significant risks. Number 3, advanced technical and financial knowledge is required to understand and evaluate the inherent risks of crypto assets investment. And number 4, the market volatility is high and the price of a token might fluctuate drastically due to technical, regulatory and marketing factors. And number 5, users may not be able to withdraw all the purchased token due to technical issues of the project or gate. Okay, so now get alpha third point. Carnival issue elevated to share 2,25,000 ES and alpha points. To celebrate the global debut of Eclipse ES on Gate Alpha, the 11th issue of Gate Alpha, Third Point Carnival is now live trade to share 2,25,000 ES and alpha points. ऑलरेडी मेरा लाइव पे ज्वाइन हुआ है बहुत सारे बंदे जिसका नाम भी मैं अभी भी नहीं पढ़ रही तो मैं आई एम रियली सॉरी. मेरा लाइव पे ज्वाइन हुआ गया है नो टाइम, गेट यूजर, स्काईफॉल, सोनून, लोकस शार्ड, आयला वाफी and many more gate users, Javed, Mio, Skyfall, Xenon, Mystery, and then You Good, Naughty, June 1, War, Mosulika 76, Kaya 07, Cristoferio, Prince Siam. Thank you so much everyone for supporting me. Thank you so much for coming my live stream everyone. Okay, so now right now and today I'm talking about that ES project. So the coin name ES, full name Eclipse, public chain ETH, and contract address already all over this here. And then project information. Eclipse is Ethereum first Solana virtual machine. SVM L2 Eclipse combines the price based pieces of the modular stake with Ethereum settlement, SVM execution, and Celestia for data availability. Each layer of Eclipse architecture is based in class and combined result in unstoppable performance. So Eclipse is backed by leading investors including placeholder VC Hack, VC DVA, Polychain, Tribe, and Verify, as well as industry leaders including Mustafa Al-Bassam, Celestia, Tarun Chistra, Goatdead, Robert BC, Anatoly, Yaki, Vanko, Solana. Okay, already all over this here everyone. And now I'm going to ES. Okay, this is our ES LAUNCHPOOL site, and then I'm going to official website and then white paper. First of all, I read this official website. Okay, so now Eclipse. So Eclipse is Solana on Ethereum. Okay, Ethereum first SVM L2. Okay, okay. Oh, wow. And Git user, hey, hello Git user, welcome to my live stream. And it's page table, Fire Mommy, and it's a natural thing. And Skyfall, everyone, thank you so much for coming my live stream. Thank you so much. Okay. So now Solana's spread the most performant battle tested execution environment in crypto with a high TPS production system. And then Ethereum liquidity. Ethereum has $80 billion in its stable coin, 66 billion in TVL, and the second largest asset in crypto. It is with market cap of $450 billion. Oh my god. So then push one chain with Eclipse, DeFi, gaming, consumer, and many more built on Eclipse Network, and Ethereum SVM. L2 combines the best of Ethereum and Solana. It's where the most performant execution environment meets unparalleled liquidity. So then news. Okay. Great investors and angels. OKX, DVA, Flow, Maven 11, Miranda Distributed Global, then Robert Ventas, Anthony, and many more, everyone, many more. So now I'm going to the white paper, okay? This is the most important. Okay, just wait. कहाँ गया है भाई? Just wait. Okay. आ गया है भाई. Okay, so right now I talk about that. The Eclipse performance thesis. Okay. And Crypto King J. Hello Crypto King J. Thank you so much for coming my live stream. Crypto King J. Thank you so much. और मेरा लाइव पे ज्वाइन हो गया है अबू आल आनन. थैंक यू सो मच. वाहिबुल कसीमी, Satoshi Nakamoto, my lovely friend. Thank you so much. Panda Creep. Thank you so much everyone for joining my live stream. And right now I talk about that Eclipse ES project. So Benjamin, Levitz, Alexander, Petrosian, Olivier, decent fans, and the Eclipse Labs team, March 19, 2025. Abstract. We have witnessed in tremendous amount of computational power becoming widely available, spurred to a large extent by the needs of LLM training and inference. Blockchain as a field has thus far not benefited from the availability of hardware such as new powerful GPUs and various other hardware acceleration techniques such as FPGAs, Smart NICs, etc. at Eclipse, we are aiming to correct this oversight. This high performance computing device utilized effectively cloud increase the amount of computation the blockchain makes available by orders of magnitude, something we refer to as gigacompute. The Eclipse performance thesis focus on building the most performant SVM layer to blockchain with a new SVM client we call GSVM Thought, a combination of software hardware co-design cross-layer optimization workload non-interference and dynamic scaling, leveraging the unique freedom of an altitude depart from the typical L1 design constraints. Moreover, as an optimatics rollup, Eclipse L1 design constraints. Moreover, as an optimistic rollup, Eclipse can take advantage of the significant additional compute capacity without being unduly limited by the speed and cost of zero knowledge proof generation. So Eclipse argues that co-designing software and hardware is crucial for modern blockchain, taking advantage of the unique position of Eclipse as an LT to overcome the limitations of, of, of the shelf hardware, cross-layer optimization across networking, runtime and storage part of the transaction execution stack, such as prefetching account data in storage at the time of transaction sequencing are essential for latency reduction at the time of transaction sequencing are essential for latency reducing. The design of GSVM aims to deliver application workload non-interference and dynamic scaling to meet growing application demands. We highlight that Eclipse position as a layer 2 fundamentally different in terms of performance constraints from layer 1 blockchains which tend to rely on generic hardware and priorities optimizing constituents over transaction execution efficiency. Eclipse address this limitation by separating security from performance, thought the fraud proof mechanism, and then shifting its focus for GSVM onto validator performance to realize the vision of what we call gigacompute in GSVM. Eclipse points out that while TPS is widely used, it ultimately a fluid mid rise, advocating for the extension of compute units CUs to account for concurrency computational core processor such as GPUs and to discourage the locking patterns that hinder GSVM's design principles. Component specific design principles include this. So network, nearline speed processing, probabilistic execution, pre-confirmation, performance-based sequencing, application-specific sequencing, and latency-optimized transaction routine, and runtime, self-improving runtime using reinforcement learning, computational abstraction, hybrid concurrency for resource non-interference, and hotspot ever hardware affine schedule database disk access, minimizing sequencer define caching, hotspot error, prevalent, and VME array hardware, accelerated SSD, aligned accounts database, and fast state commitments for light client. So then, an analysis of state connection in Solana highlights some of the shortcomings of the current currency model. Longer term better concurrency for modern hardware requires moving beyond Solana currently used pessimistic approach, exploring more parallel friendly scheduling and data formats. Lastly, this thesis outlines how three application domains can benefit from the extra processing capacity of the GSVM. So AI gaming and deepin in the long run, all three domains require large scale compute and affiliate concurrency precisely with GSVMs. Gigacompute ambitions aim to deliver. And number one, introduction. The global eclipse is to deliver the most performant SVM layer to L2 network, although the SVM stack is already performance oriented, thus providing as desirable starting point. We take further advantage of the unique opportunities that Eclipse has as a layer 2 chain that are not available in the L1 blockchain context. Indin and optimistic rollup effectively separates integrity concert from performance consideration. The former are satisfied with the help of fraud proof that allow outside parties to mount challenges if the rollup operator is suspected of violating computational integrity. Similarly, concern around censorship resistance can be addressed with the help of focused transaction and Eclipse has 2-3 so long as the underlying data availability layer is able to keep up with the throughput and the fees. The rollup collect cover operational DA and L1 cost, and re-execution for fraud proofs is not overly expensive. We can directly focus on improving the performance of the validator. This separation of security from performance is at the heart of Eclipse design. With the security foundations in place, Eclipse can build an supercomputer. Fortunately, we have seen great deal of progress in unlocking a significant amount of hardware performance. Some of the most recent advanced in GPU based processing and FPGA based low latency computation have become significantly more popular as a result of recent AI and LLM breakthrough. We at Eclipse have a real opportunity to bring much of the same hardware progress and computational addresses to the field of blockchain, bringing this. Number 2, the Eclipse performance thesis version 0.9. So computational capacity orders of magnitude more than current chains support to the blockchain context is a path to what we call gigacompute. At Eclipse, we follow these guiding principles for the new Eclipse GSVM client. Number 1, software hardware co-design. So we agree that careful software hardware co-design truly unlocks the performance potential of modern blockchain. In the rest of this document, we will illustrate this with numerous examples ranging from smart NIC devices with support for near-line speed execution very close to the network to custom support for faster key value store database. With the help of Zonet, NVMe devices, and custom firmware, we claim that relying on out-of-the-box hardware will not achieve breakthrough performance, and that customizing both to software and hardware to the workload we can profile and understand will provide the best outcomes. So admittedly, we at Eclipse are significantly inspired by the tremendous process that we have witnessed in applying hardware software co-design in the domains of deep learning and LLMs. We want to bring similar level of performance enhancement to on-chain computing. And number two, cross-layer optimization. Our goal is to see or design to the major three components of the GSVM client: networking, runtime, and storage to fully take advantage of cross-layer optimization opportunities. For example, performance-driven sequencing can record a transaction and signal the storage backend to prefetch account data drastically reducing I/O stalls, coupled with concurrency control awareness. Okay, I'm sorry. And generally lead to near zero case misses. And number three, workload non-interfaces. The design principle of Eclipse is to deliver the ability to run application without interfaces. If a DEX is experiencing a significant load, it should not adversely undermine the availability of other users or play on chain game. The principle of non-interference aligns with the approach of local fee markets in Solana. This principle implies that isolate spikes for some hotspot and some application do not degrade the performance for all users. Local fee pricing is similarly hotspot specific. This also means that many advantage of L3S can be delivered within the context of the shared address space of an L2. We aim to expand these principles to other aspects of GSVM design beyond the phase. Specifically, we want to make sure that we are able to ensure core affinity for the scheduler so that execution can happen on multiple across without. So CMML 1978, please bro, remove your this link. I don't like this, you also know. So goodbye. And Gate user, good, thank you so much for coming my live stream, Gate user. Panda Crypt and many more, Gate user, thank you so much everyone. Nick Girl W, Gate user, everyone, thank you so much for coming my live stream and also supporting me. Rotoba, thank you so much for coming my live stream, Rotoba. So now number 3. Okay, and number 4, dynamic scaling and chain elasticity. So our goal is to provide into capacity to scale in application demand grows. Capacity may also scale together with demand. This can be accomplished by dynamically adding more execution cores or provisioning additional storage and VME when the Eclipse performance. This is version 0.9. And then limitations of layer 1 blockchain, layer 1s. So Sniper BM, my lovely friend, thank you so much Sniper BM for coming my live stream. Sniper BM 12. Okay, I am right, you also right. 1 hour later I am trying to my next market analysis live. Okay, I'm trying. So everyone, please stay or supporting me. Okay, Sanun, get yours, Lee Voxy, I love Waffle, and many more get yours. Okay, thank you so much everyone. So now future Solana CPU powerful multi-core CPU which is 60% core. So okay, all over this area everyone, all over this area you also see that. So now figure 1 hardware requirements for nodes on Solana, Polkadot and Never. And Sniper VM, good morning everyone, good morning Sniper VM, thank you so much. And Ala Wafi, Assalamu alaikum, Ala Wafi, Kifa Halik. I don't know your Arabic language, that's why I'm not answer this question in answer. Okay, and Christopher, no time Skyfall again, and Sniper VM, thank you so much bro for commenting here. Thank you so much. Okay, okay, now Matin34, okay, thank you so much Matin for coming my live stream. Everyone, thank you so much. So now figure 1 hardware, okay, a new demanding application goes live. This is an form of horizontal scaling that can be satisfied with more capacity allocated across the layers of the system, including nodes, execution cores and storage devices. So our goal is to deliver a new GSVM client for the Eclipse rollup based on these principles. Take together these 4 principles guide every layer of the Eclipse GSVM client, from the networking pipeline in committing the final state in more detail in discussion can be found in section 1.4. So now 1.1 limitation. So now number 1, okay. Capsicum. Chinese. So 1.1 limitation of layer 1 blockchain, okay. Similarly to those who think of operating system in terms in hardware that was available in this 19th century, 6 blockchain design have been largely blocked by what is possible in the layer 1 blockchain space, where the validator nodes run client software on a variety of operating systems and hardware platform, and perhaps even different client implementations using a wide area BFT consensus. In particular, we observe 2 major limitations in typical layer 1 designs. So consensus focus. So wide area consensus is usually the focus of performance oriented work, in part because in time to achieve consensus in a wide area setting is typically much larger than transaction execution time. This is despite major straight in the area of speeding of consensus, such as a hot stop family of algorithm 711 used for example by Espresso shared sequencing or DAG based work such as narwhal and bull shark. 12 and 14. Some of these ideas have migrant to rollup that were applied mainly to sequencer design. 10, 15. Unlike this project, we believe that decentralization can be achieved through a combination of other means. So our reliance on generic hardware. So although they require a fairly significant amount of computational capacity as the figure 1, it is debatable whether the actual hardware utilization is particularly high. In section 2, we show that out of the box, Solana does not use the available CPU cores. 4. So matrix, why do we need giga compute? So particularly efficiently, not to mention GPU cores. In fact, blockchain developers are not given even what a higher end phone would be able to enjoy in terms of compute capacity. We point out that in most cases, layer 2 blockchains have not gone beyond the assumption that are used by layer 1s and omissions that we aim to rectify and eclipse. 1.2 Matrix, we need gigacompute. The choice of the performance metric for which we will optimize in important. Some optimization will impact some metrics more than others. Therefore, understanding we have chosen one particular trait of over another requires knowing the rationales behind our initial choice of metric. So latency, the first and most obvious metric is response latency. It is the one aspect of preference that user experience more directly. Latency is situational. It is helpful when trying to understanding and feasibility. All over this side, everyone. And then TPS, transaction throughput, typically measured in transaction per second. TPS. Koi. Hai koi. Attack sila kanda. Ye box bida. Again ni. So per second TPS is the most widely discussed metric. This metric and universal and composable, where each blockchain component has a specific volume of transaction processing capacity. This unlocks the availability and optimize each component in isolation and to focus optimization efforts on the components with the lowest throughput capacity. Ensure is the most popular and officially endorsed framework for writing Solana programs. It is safe to assume that the vast majority of Solana programs will utilize the Anchor framework. Number 5, beyond gas. So TPS is certainly helpful when thinking about consensus performance, specifically recent research such as Mysteries T by Bevel 8L12 and the Hotstop algorithm Family 9 reveals TPS nearing 1 lakh, which mystically highlighting reduced latency. Clips is able to achieve 1 lakh TPS in a lab setting using Solana proof of history. Our BFT mechanism. One problem with TPS is that not all transactions are alike. There are many academic papers that cite throughput numbers in excess of 50 to 100k TPS, but this often measured to transfer only as opposed computation heavy transaction. Consider both solo and fast transaction types. Solo transaction are small messages that cause a large amount of computational, for example a zero knowledge proof, while fast transaction are simple native token transfer. General, generating zero knowledge proof can consume order to magnitude more in terms of processing cycles that a simple tokens transfer. However, each transaction count quality in terms of statistics will clearly requiring a vastly different amount of computation to execute when responding performance numbers sitting in higher TPS may. Okay, and then number 6, expect like custom pricing for database access operation. 18, computational units CUS in Solana serve a similar purpose as gas in Ethereum, but with key difference in their calculation and detailing fee structure. For example, we omit many important details related to things like rent, preferring the interested reader to ZAO. 19, similarly to what is found in other metering approaches, the high level aim is to quantify the computational effort required to process a transaction, including the execution of instruction data, storage, and bandwidth usage. Each operation performed within a transaction consumes a specific number of CUS 2023, and the total CU consumption determines the computational resources utilized to prevent runaway process and ensure network stability. Solana imposes limits on CU consumption. The maximum compute units allowed at the moment are shown in figure 3. These limits are critical in preventing runaway programs that loop or run immediately or consume excessive resources. By enforcing the CU limits, Solana ensures that transactions are processed efficiently and the network remains stable. Transactions are processed efficiently and the network remains stable. Our approach at Eclipse is to start with the CU approach used at Solana, primarily thinking of our performance aim as increasing CUS per second. We plan to extend the CU approach in several ways. So then, Lutoba again, Sergio Banani, many more Git user, Nasser Web 3, UID 1440. Okay, everyone, thank you so much for coming my live stream. Thank you so much. Okay, thank you so much. So gas are CPU based and metering and fundamentally better sweetened and single threaded execution blockchains. There should be not reason we there cannot multiple application running and consuming and significant amount of compute on different machine cores with no interference. As such, we believe that CU thresholds such as those in figure 3 are limiting for a system like Eclipse that targets dynamic scaling. There is room is discourage operations that make it difficult to follow the Eclipse design principles by pricing that higher. An example of this, charging for exclusive locking. Okay, and 1.4 GSVM design principles toward gigacompute beyond the three overarching principles that contribute to the performance of Eclipse. Number 1, software hardware. Number software hardware co-design, and then cross-layer optimization, and number 3, worker non-interference, and number 4, dynamic scaling. We propose more design principles that we component specific as shown below. So in 1.41 network, the reader is referred to section 3 for more details, and then nearline speed processing. Many transactions can be handled much faster close to the network card, reducing the latency. This is often described as near data processing opportunities, including operations such as signature verification on smart NIC, as deduplication and aggressively identifying transaction likely to fall. So then probabilities, execution, pre-confirmation, and then performance based sequencing, and then application specific sequencing, and then latency optimized transaction routing. So then 1.4.2 runtime. The reader is referred to section 5 for more details. Okay, GSVM design principles toward gigacompute, a self-improving runtime that relies on reinforcement learning. Profile guided optimization is a time-honored principle in modern run times and in the optimization of complex systems. In general, at Eclipse, we plan to amplify this principle by training on prior transaction histories and on ongoing traffic patterns using reinforcement learning. Computational abstraction. Given that some apps or programs are relatively simple, computational abstraction can be used on compress or short circuit the computations in way where a portion of transaction can be computed near the where, ideally on the smart NIC, avoiding unnecessary data copying and reducing the end user latency. So then hybrid concurrency to support transaction resource non-interference. Will a number of chains such as Aptos, Sui, Monet, and Solana focus on parallel transaction processing? They often suffer from a low observed level of parallelism. So we aim to improve on that in Eclipse by using a finite level of parallelism and shifting to hybrid model of optimized of processing currency. And then hotspot ever hardware affine schedule utilizing hundred of cores, resulting in computational non-interface. And then 1.4.3 database. The reader is referred to section 6 for more details. And then disk access minimizing sequencer driven caching, as the cost of cold fetuses from disk is quite high even for modern SSDs. Our aim at Eclipse is to make sure that we minimize key value cache misses and blocking disk access by pre-fetching relevant account data at sequencing time. Hotspot aware parallel NVMe array back in supporting data non-interfaces. So given that different computational hotspot can be located on different NVMe devices, their access can be done in parallel with virtually no interfaces, thus helping with dynamic scaling. This hotspot can be dynamically migrated across the storage device array as workable chains. Hardware accelerated SSD allocated accounts database. At Eclipse, our goal is to move error from the RocksDB database to it used by Solana to one that results in much more alignments with the underlying hardware. So paper organizations, and then first state commitments for light lines. Okay, already मेरा लाइफ पे जो Nginx and Calypto 2020 GBA walk get user CryptoZone and many more get user. Thank you so much for supporting me, or thank you so much for coming my live stream, my all lovely friend. Thank you so much. Okay. So now number 1.5 paper organization, the structure and reminder of these documents in follow section to discuss our transaction contention and opportunities for greater parallelism. Section 3 illustrates opportunities for processing all close of the network that help GSVM achieve nearline rate throughput. Section 4 talks about our approach to transaction sequencing and dynamic scheduling, which we refer to as performance-based sequencing. Section 5 is a collection of smaller optimization that nevertheless give an idea of the specific possibilities pertaining to Solana. Section 6 layer discusses the storage layer in detail, specifically focusing on acceleration of options for key value storage, specifically those that rely on specialized hardware. Section 7 contain a discussion of these classes of application that will benefit from the performance characteristics of GSVM, AI, gaming, and deepin. Finally, section 8 concludes. And Muata Al Mahdi, hi, hello, welcome to my live stream, bro. And how are you? So then number 10, the inaugural meme coin incident. And number 2, toward greater level of parallelism. Number 2.1, hello, Kaifa Halek Sadiq. Alhamdulillah, Muhammad Mahdi, Alhamdulillah. And good morning everyone. Okay, good morning K07. Okay, again thank you so much. सभी को बहुत बहुत शुक्रिया है दिल से. And bro, सादिक, मैं ज़्यादा अरबिक नहीं समझती हूँ. आप चाहो तो फिर इंग्लिश के ट्रांसलेट करके भी बता सकते हो. मैं ज़्यादा नहीं समझती हूँ. मैं ज़्यादा समझ नहीं पाती हूँ अरबिक लैंग्वेज. ओके, जिसके लिए मैं ये कह रही हूँ. So then 11, and then unlocking more parallelism. Okay, and then 2.2, unlocking more parallelism, transaction commutability, toward line speed processing for GSVM, optimistic currency, hybrid concurrency, and then number 3, near line rate transaction processing. And bro, आप भी स्टीमर होना चाहती हो मेरी तरह से, बोलना चाहती हो और स्टीमर होना चाहती हो, तो फिर आप मुझे बता सकती हो. मैं आपको मदद करने की कोशिश करूँगा. ओके. And 3.1, toward line speed processing for GSVM by performing partial of complete transaction, so handling at The network bound array Eclipse GSVM client can speed up or simplify the validator pipeline. Specifically, we envision the following capabilities at nearline read speeds. So, filtering, filing, transaction, and transaction duplicates, and then reference. Okay, all over this here state. Now, efficient signature verification, that state prefetching and then pre-confirmations. So then toward line speed processing for GSVM. So 3.1.1 smart NIC and FBGAS, and then toward line speed processing for GSVM. Okay, so now 4 point performance based sequencing, 4.1 priority based sequencing, and then 4.2 transaction scheduling. Number 1, reduce latency. Number 2, maximize resource utilization. Number 3, relax ordering. So then hotspot island. So hotspot island 4.3. okay, and then 4.4 priority based real time scheduling. 4.5 a motivating example, and then 4.6 dynamic scaling. 4.7 conclusions, and then 5 optimize the runtime for giga compute. 5.1 runtime consideration, and then 5.2 execution model, and then so all over this here everyone. And शाहजलाल, हाय, हेलो शाहजलाल, कैसे हो आप? सो मैं सभी के लिए कहती हूँ कि मेरे तरह आप भी स्टीमर होना चाहती हो, आप भी यहाँ से बातचीत करना चाहती हो, तो फिर मुझे बता सकती हो, मैं आपका मदद करने की कोशिश करूँगा। मेरा कमेंट सेक्शन में आकर बता सकती हो, मैं आपको हर चीज़ बताने की कोशिश करूँगा। और उसके साथ साथ पर्सनली भी मुझे बात करना चाहते हो तो फिर मेरा टेलीग्राम आईडी के पास जाकर मेरा नाम लिखना ARTHOR, मैं फिर से कह रही हूँ, मेरा नाम लिखना ARTHOR, उसके बाद मुझे मैसेज कर देना, मैं आपको मदद करूँगा। फॉर्म भी भेज दूँगा, आप उसको फॉलोअप करने के बाद भी स्टीमर हो सकते हो। ओके, सो नाउ 5.4 unique kernel design, and then 5.5 conclusion. Number 6 optimizing storage for giga compute, and number 6.1 key value storage and flash memory. 6.1.1 flash support, and then 6.1.2 performance concert. 6.1.3 indexing data structures. So then key value storage and flash memory. Okay, all over this here. So Mohatham Mahdi, bro, I don't understand, bro. I'm really sorry, I don't understand your language, that's why I'm really sorry, bro. And Trader coming my live stream, Shakani Nakamoto, thank you so much. And Quiz Mozib, thank you so much everyone for coming my live stream. So right now I'm going back in my front page, read that fast, and then I'm closing my live stream everyone. Almost मेरा लाइव खत्म होने का समय हो चुके हैं. So get LAUNCHPOOL newly added Eclipse's ES stake BTC ETH ES to earn rewards delivered in real time. So Eclipse ES will be launched on Get LAUNCHPOOL stake BTC ETH to earn ES token reward every hour. So airdrop details. Staking period July 16, 2025 and 10 July 26, 2025 at 10 UTC, and total staking reward line like 90,000 yes. So stake to earn now. And Mohammed, okay, and Lucas shot, should we hold or sell? So this is our market analysis live, this is our project live. So next I will try to coming my next live in market analysis. Okay everyone, just wait for my next market analysis live. And Lucas shot, any coins recommended? Bro, I'm also say that This is our yes project. Okay. So now unlocking rules 100% unlock a launch pool allows user to stake early. You can stake your asset before the project officially launch, ensuring you start earning reward immediately. Once mining begin and reward distribution, the system will distribute token rewards to user spot account every hour based on the proportion of asset stake by each user. Get launch pool frequency. How to participate? So log in your Gate account and complete identity verification and navigate to Launchpool. Hold at 0.0000001 BTC or 0.0000003 ETH and 0.2 ES click stake. So exclusive staking limit privilege for VIP user all over this year. And then project information. So Eclipse is Ethereum first Solana virtual machine SVM. L2 Eclipse combine the best pitches of modular stake with Ethereum settlement, EVM execution, and Calistria for data availability. Each layer of Eclipse architecture is based in class and combined result in the unstoppable performance. Eclipse is backed by leading investors including placeholder VC, Hack VC, DVA, Polychain, Drive, and Parafi, as well as industry leaders including Mustafa Al Wassam, Calistria, Tarun Chitra, Gauntlet, Robert VC, Anatoly, Yekomju, Solana, Jainer, Sherwani Jitu, and Santiago. So all over this here everyone, you also see that, and you also read the whole page and all over this here everyone. So almost my live almost closing time, so I check my time and then I'm closing my live stream. Okay, so everyone, goodbye and see you again in my next market analysis live. So wait for my next live. Allah Hafiz, goodbye, see you again, my all lovely friend and all lovely my dearest friend and all sweetest friend. Goodbye, see you again next live, and assalamu alaikum everyone.